part D.5, project to overflow detection. So this time we do detection. So it is different from the previous video. We do estimate. So detection, what we get should be precise information, right? Precise information. The estimate, that gives us very close information, not exact. All right, so let's look at the method we use here. Determine the overflow bound. So determine the overflow bound, little n max. Yeah, this number, but we want to get a precise number, not estimate, not close estimate. Yeah. So how to get that? We will use a property of the overflow. What is the property of overflow? Key property of overflow. Yeah. The meaning of overflow tells us that property. To understand that, we need to start with the basic overflow caused in an operation. Yeah. Here, let us consider addition. C equals A plus B. Yeah. In our Fibonacci, we have the operation Fn equals Fn minus 1 plus Fn minus 2, right? Yeah. So here, let us use the general C equals A plus B. Now, when you do this operation where A and B very large, there is a possibility this operation may cause some overflow issue. All right. When overflow happens, what will you get? What will you get? Okay, yeah. So in the computer, so there is no error message. No error message. You cannot see anything, any indicator regarding overflow. So that's the reason we need to do detection. Otherwise, we don't need to do detection because no sign, no signal, no indication about the overflow. So we need to do something to detect the overflow. Yeah. So no error. Yeah. But the result would be truncated. All right. Suppose we use the unsigned long integer, 64-bit number. So A plus B. The result, you get the number you need more than 64 bits. You need more than 64 bits. There is a chance, right? So you need more than 64 bits. What would happen? Truncation. You only keep the last 64 bits. The higher bits will be truncated, gone. You lose the higher certain number of bits, higher than, 64th bit, starting from the right. After the truncation, is the result correct? The result won't be correct, right? After truncation, the result won't be correct. But with this understanding, now we can design our overflow detection method. All right. The method is very simple. All right. Yeah. So the detection design in this way. All right. Yeah. You do experiment, right? Fibonacci number iteration, calculate. So you still write your program, do calculation. Every time after you find a new Fibonacci number, you do detection. Okay, so here, let me just write the general detection way. Suppose you have C0 equals A plus B. After one Fibonacci calculation, so this one corresponds to one Fibonacci number calculation. Okay. All right. After one Fibonacci calculation, you need to check if this value is correct or not. If this value has not been truncated, if there is a truncation or not. Okay? Truncation corresponds to overflow, right? So you need to detect truncation, all right? Yeah. So the truncation and overflow hand in hand, right? Hand in hand. They appear simultaneously. Now we detect the truncation. All right, yeah. With truncation, so here, our criteria, yeah, with a truncation, all right, yeah. C0 minus A will not be equal to B, because C0 is a truncated value. Truncated value. You lose certain number of bits by the truncation. So this won't be true. If you compare these two numbers not equal, that means truncation occurs and overflow occurs, right? Truncation occurs, overflow occurs. You find it. You find it, all right? In other words, after you get a new Fibonacci number, you use it to minus one of the old, one of the, when you do the addition operation, one of the operand, right? It won't be equal to the other operand. Then you detect. So overflow occurs. That's the one. So you find the upper bound, but this one, upper bound, little n max, won't cause overflow, but this number plus 1 would cause overflow. That's your detection separation point. Yeah. So you stop. Yeah. Here, the last comment. Yeah. Because some students, they like to use Python. Yeah. Python, big integer already take care of the overflow issue. Yeah. So for Python, so you can skip this step because you won't get it. Okay, skip this step. Yeah. I won't impose any penalty for the skip. Okay, you are fine because you try your best. The previous method 1, you do the estimate, right? You can do in Python. You can still calculate that close estimate. You can calculate that, but this step you don't have it. You couldn't make this detection. You just skip it. All right? Yeah. Don't worry. You're fine. Yeah. All right. So let me stop right here for method number 2. Overflow detection.